whenever you're working through word problems, make sure you're paying close attention to units. Oh, thank you. Make sure you're paying close attention to those units, because if they said something like gives the time in minutes, and then they ask you for something with hours, you have to make sure you're making that conversion. Okay, so it gives the time in hours, that the mound is at a certain volume in cubic inches. So I'm going to pay attention to that. Cubic inches. What is the volume after 14 hours? All right, my hours and my hours match up, so I don't have to do any conversions on this. If they said, what is the volume after 14 days? Then I got to change days to hours. So 14 days is equivalent to so many hours, and then continue on. Okay, so we have our equation here where we're going to have t equals, okay, and we want to do it with 14. So this is 14 is going to be equal to the cube root of 5v minus 1. All right, so to undo this, I can cube each side. Oops, yeah, cube each side. When I cube each side, see, I got my calculator on this one. So 14 cubed ends up being 2744 equals just 5v minus 1. And I'm trying to find the volume, okay? It says, what is the volume? So I'm trying to solve for v. So all I would do is add 1 to this, so 2745 equals 5v. 2745 divided by 5 ends up being, v is 549, but for these problems, volume is in cubic inches, so this is inches cubed. Like I said, just make sure you're paying attention to your variables that you're working with. What are the units on each one? Okay, any questions on the warm-up problem or any of the homework problems, board problems? Okay. All right, so today we're going to work with multiple variable problems, where now I'm going to have multiple variables, as in I could have multiple x's within the same problem. We're also going to start talking with extraneous solutions, and we've done this before, not this term necessarily, but extraneous solutions is you do all the algebra and it says 2 answers. Well, one of them might not work. If you put it back into the problem, it doesn't work, so we have to do our checks. And if it doesn't work, that's called an extraneous solution. And then lastly, we're going to look at how we can solve graphically using Desmos. All right, so we already took a look at that board problem. There's our other problems. So here we go. 6.5, day 2, solving with radicals still. So radical equations with multiple variables may have these extraneous solutions. Again, that extraneous solution just means that you do all the algebra and it tells you that x is 2 and x is negative 5. And you go back into the problem, you put in 2, yup, it checks out, you put in negative 5, and it doesn't work. Negative 5 would have been an extraneous solution. So this is adding an extra step into your solving to make sure that you actually have the correct answer. All right, and then really the same thing's happening. We're going to isolate the radical, use the inverse power or undo the radical, same thing. Solve, but then this fourth step is very important. We want to check for any extraneous solutions. That last piece of check is very important. And I have students in college algebra right now, I have students in AP calculus that I will go through and I will say, check your answer, check to make sure it works. And still, it's the most often overlooked piece. They do not check it, and they tell me it's this and this. And I say, nope, it's actually only one of those. And I take points off. So make sure you are checking for those extraneous solutions. The check only takes 10, 15 seconds. It doesn't take that long. All right, so there's really nothing new on this slide. You don't necessarily have to write it down word for word. Keyword on though is extraneous solutions. Check for extraneous solutions. All right, so let's actually do it. So when I say multiple variable problem, that's what it means. I could have more than one x going on in this. We are going to tackle it just like we were doing all our radical stuff from yesterday. We want to isolate that radical. So how I would do that, I would add 5 to both sides. And so now I have the square root of x plus 7. But on the right, now I have a binomial of x plus 5. All right, well, I want to eliminate the radical, and I can eliminate that radical by squaring, but then I have to square what's on the right as well. So I'd encourage you, or you need to, put parentheses around it, because it's not x plus 5 squared with the squared only on the 5. It's that whole thing. Everything on the right side of the equal sign has to be squared. And remember, x plus 5 squared means x plus 5 times x plus 5. We just did all that work with rational exponents, where we simply put that exponent on each term inside our parentheses and continued on. Well, that was with multiplication inside our parentheses. Addition, subtraction in our parentheses, we have to expand this out with FOIL. All right, so this would be x squared plus 5x plus 5x plus 25. So x squared plus 10x plus 25 is now what I have on the right. And then on the left, made that a lot easier to work with. That's just x plus 7. No longer have any radical going on in this. All right, well, I want to isolate my x now so I can solve. I'm trying to figure out what x is. So in order to figure out what x is, I would have to subtract 7, and I can only subtract 7 from a number. I would have to subtract x, and so I'm going to subtract the x from 10x. I can't subtract it from the x squared. So that leaves me with 0 on the left, which is what I want. X squared plus 9x plus 18. So this should bring back fond memories of Chapter 4 in Algebra 2A. We have a quadratic now that we have to solve. We spend an entire chapter in Algebra 2A tackling how to solve quadratics. Okay? First thing, is this factorable? All right, we're in Algebra 2B now. Factoring is something we got to be solid on, because we're now in an intermediary step where we have to factor in order to continue on. Those that had me for Algebra 1 or even Algebra 2A, I use this cross method, where the top of my cross is always a times c, because remember, standard form of a quadratic, ax squared plus bx plus c. And so on the top of my cross, I always put a times c. So in this one, it's 1x squared, so my a is 1, times 18. So I have 18, I put that in my cross. So this cross method is just a way that I stay organized to factor. And then my bottom term, or my bottom piece of my cross, is simply that b value. And I'm trying to think of two numbers that when I multiply, I get this, but when I add, I get this. So two numbers multiplied to get 18. but add up to be 9. Joel, what are those two numbers? 6 and 3. Okay, multiply those, I get 18. Add them up, I get 9. So I draw that little cross, and you'll see me in any factoring problems, I'll probably always draw a cross. If this had been like 19 on top to get 9, we'd say, oh, it's not factorable. Well, then we got to go to our other options that we have. Okay, how else can we solve? So fortunately, this one was factorable. Because my a is 1, I could immediately put in there x plus 6, x plus 3 equals 0. So therefore, what is x? Alexis, what do you say? -6 and -3. So we got all the way down to step 3 of solving multiple variable equations, and now we have to check. No way around it, you have to check. So I'm going all the way back to my initial problem here. All right, and I'm going to put in for x being -6. So the square root of -6 plus 7 minus 5, I'm trying to figure out, okay, does that equal x, which was my -6? -6 plus 7 is 1. Square root of 1 is still 1. 1 minus 5 does not equal -6. Okay? 1 minus 5 would be a -4. So -6 is an extraneous solution. So that one is actually not a solution to this one. Let's check -3. So -3 plus 7 subtract 5. Does that equal a -3? -3 plus 7 is going to be a +4. Square root of 4 is going to be 2. 2 minus 5 does equal -3. Checks out. If you do your check and none of your answers work, you made a mistake. Go back and look through your workings. You made a mistake somewhere. Okay? It's very common for one to be an extraneous solution, but you're never going to have both of them being extraneous solutions. Okay? So, final answer for this one, if it was on a test, I would want you to tell me the answer is -3, and that's it. That's the only one that will work. You told me -6, -3, and you moved on to the next problem, I'm taking points away. Because -6 is not one, and we forgot to check. All right. You do this one on your own, in your notebook. Give you 2, 3, 4 minutes here. Follow through. I will tell you you'll get 2 solutions for x when you do the algebra. Check them. Let me know if both are true or if only one is true. Okay, so should be able to work through this one. End up with x minus 3 on the right. Square both sides. Again, squaring a binomial creates a quadratic. Set one side equal to 0. Factor. End up with 10 and 1 for possible solutions. Take those possible solutions, do your check. Realize only 10 works, 1 does not work. So your only answer on this one would be 10. Okay, so again, that factoring is a step in the process now. We need to be able to factor to continue on. All right, let's take a look at one with rational exponents. Okay, even though as a rational exponent, we still treat it the same way. This one even has x on the same side of the equal sign, so that's no problem. I want to isolate that radical or isolate the rational exponent. So if I add x to both sides, all I'm going to end up with is x on the right, and then 5x minus 4 raised to the 1/2 power on the left. To undo that 1/2 power, I'm going to square both sides. So now this becomes x squared on the right, and all I'm left with on the left is 5x minus 4 equals x squared. Same thing, we're going to create a quadratic out of this. So this would be x squared minus 5x and plus 4. So minus 5x plus 4, and set that equal to 0. I do my quick cross to see if this is factorable. Two numbers I can multiply to get 4, but add it to be a -5. Yeah, I could do -4 and -1. So now I have x minus 4, x minus 1. So possible solutions are 4 and 1. So I ran through this one a little bit faster, but the process is the same. Even though it's a rational exponent, we want to isolate that and then undo that rational exponent. Had a quick factoring in there. Last step is to do the check. All right, so 5 times 4 minus 4 raised to the 1/2 power minus 4. Does that in fact equal 0? All right, 5 times 4 would be 20. 20 minus 4 would be 16. Square root of 16 is 4. So 4 minus 4, yep, we end up with 0 equaling 0. That one checks out. We do the other one, 5 times 1 minus 4, all raised to the 1/2 power, minus 1. Does that equal 0? All right, well, 5 times 1 is 5, minus 1 would be 4. 4 raised to the 1/2 power is the same thing as square root of 4, so that's 2. 2 minus 1 is 1. 1 does not equal 0. We got a guest teacher today. A round of applause for Mr. Mitchell, showing him the cross method. And they're like, Mr. Mitchell never showed us this cross method. What the heck? This is a lot easier. He just told us to do it out of the blue. You got to know.
You just got to figure it out in your head in my class. I don't teach. You just got to figure it out.
Yep.
Right?
He gives you the example and says, nope, 1 is the answer, 1's not the answer. Ooh.
Which one was extraneous? 1. Cross that off, right? Get rid of that.
Yep. We're getting there. All right. Avery, do you have a question? Oh, thank you. That should be 4. Ooh, that's going to make a difference. Okay. So 5 times 1 is 5. Square root of 1. So this one actually, good catch. This one does end up being 0 and 0. Ooh, good catch. Thanks for bringing that up. Because, okay, so 5 minus 4 is 1. Square root of 1 is 1. 1 minus 1 is 0. 0 equals 0. So both of these work. Okay. There we go. X equals 4 and x equals 1. All right, couple more. Well, this is good. You need to see these examples. Okay, the more you see, the better prepared you'll be. I actually have 3 more, counting this one. Okay. All right. Now we have 2 radicals going on. We need to pick one to isolate. Well, in this case, in one step, we've actually isolated both of them. But still, you got to keep in mind, okay, I got to isolate the radical. Sometimes you might have to do it more than once. This one is actually nice because I could just say, well, this is square root of 3x plus 2. And then if I move this one over, in a sense, I've isolated each radical on its own. Isolating meaning I get it to one side of the equal sign with nothing else there. Well, if I'm going to undo that squaring, square root, I'm going to square both sides, and then boom. Now all I have is 3x plus 2, 2x plus 7. No quadratic I have to worry about. All I have to do is a simple solve, so I'll subtract 2x from this side, subtract 2x from this side. But then I want to get x's on one side, numbers on the other side. So I'm going to subtract 2 from the left to get it to the right. So all I have here is x, and then all I have here is 5. So this is simple solving of a one variable equation, or simple solving of a degree 1 equation. We don't have to worry about setting equal to 0 or anything like that. So x equals 5, but still we cannot forget our check. So if we do 3 times 3 plus 2, and then minus 2 times 3 plus 7, does that actually equal 0? I'll tell you it does. It is 5. See, look at all this stress I'm taking away from you when you do your board problems. You see I make mistakes all the time. Should be 5. All right. Now something like this, we do have 2 radicals going on. And if we move, again, we want to isolate one of the radicals. So I'm going to take this and add it to the other side. But now I have a binomial 1 plus root x. And then this is still square root of 2x plus 1. This was the first step of isolating the radical. This one on the left I'm focused on, so I'm going to square each side, and then I only have 2x plus 1 on the left. Now this, we can't forget how to do these. I mean, we still do it with FOIL, but this gets back into foiling with radicals in there. So 1 times 1 is 1, plus root x plus plus x. So root x times root x is just x. These two I combine. If I have 1 apple and I add another apple, I have 2 apples. If I have 2 root x's, or 1 root x plus another root x, I have 2 root x. So I have 1 plus 2 root x plus x. So this is 1 plus 2 square root of x plus x. Reset. I have a radical in my equation now that I want to solve. I need to isolate that radical on the right. All right, so I'm going to isolate that radical by subtracting x and subtracting 1. So subtract x, subtract 1. So now I have just x equals 2 square root of x. Okay. I want to undo that, so let's square both of these. So I have x squared now equals 4x. This is multiplication, so this exponent applies to both pieces. X squared equals 4x. I have a quadratic that I want to solve, so I could say x squared minus 4x equals 0. This is a quadratic. We could look at, if we could factor it, well, this is just x squared and 4x. I can actually factor out a greatest common factor, and then that makes things really easy. So that tells me then that x would be 0 and a positive 4, potentially. But to confirm, I still need to do the check, back with the original. So square root 2 times 0 plus 1 minus square root of 0. Does that equal 1? So square root of 1. So 2 times 0 is 0, plus 1 is square root of 1, which is 1. 1 minus 0 is still 1 equaling 1, so this checks out. Square root of 2 times 4 plus 1 minus square root of 4. Does that equal 1? So 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. Oops. Back. Square root of 9 is 3. 3 subtract 2. I do end up with 1 equaling 1, so that one works. So both of these are true. Didn't have any extraneous solution. All right, last thing I want to show you is graphically. So this is something that'll help you out with math for the rest of your math career. If you are ever given an equation and you have the option to graph it, you can solve any equation graphically. Okay? If you have the option to use either graphing calculator or use Desmos, you can solve any equation graphically. I mean, we run into this in AP calculus where maybe we have some crazy big function that has like logs or something on one side. On the other side, I have some crazy exponents going on that's just a mess to try to do by hand. We can do it graphically. This is saying, getting back to just the foundations of what an equation is. This is saying this piece right here is equal to this, and it's going to happen at some value of x. Okay? So this is not the graph of it, but say I had two lines that I graphed. This was some equation, y equals, say, 3x minus 7. This was some equation, y equals a negative x plus 5 or something like that. If I set up the equation to say 3x minus 7 equals a negative x plus 5, those will be equal to each other right there at that point where they intersect. Okay, so just don't get it caught up in you have these crazy equations going on. Think of them separately. This side has to equal this side. If I think of it graphically, it's only going to happen at one specific point, or it might be two. All right, so if you go into Desmos, and you can just watch me do it, so let's do it real quick. All right, if I wanted to graph this, so the first one was square root of 5x. I should have brought my regular keyboard. Let me get my regular keyboard. So if I have 5x plus 4, and then minus square root of x, I'll graph that, and I get this kind of funny looking check mark type shape. And then the second one was just equal to 4. So in Desmos, I could say y equals 4. And then that's going to give me my two graphs. The only place these are equal to each other is right there. So you can put it right in Desmos, and it'll tell you then that x is equal to 9. Okay? You didn't have to do anything crazy with it. Simply graph each side of that equation, figure out where they cross. Desmos is nice. It'll let you literally click on that point. It'll give you the coordinates. And I'm trying to figure out the value of x that makes it work. It only works at 9. If I put in 2, or I'm sorry, right here 2, I would get, oh no, those aren't the same values. I put in 6, those aren't the same values. At 9, they are the same. So when I go back to my problem here, I could do just a quick sketch. The one was that funny check mark. That one's right here. I know right here at 9, x equals 9. I'm done. All right, so you're going to have one problem in your homework where I just want you to do it with Desmos. If I gave you a problem on the test and I gave you 2 lines, if I graphed it for you, but then I'm obviously not going to draw a point at the intersection or something, you need to know that where they intersect, that's the answer. Okay, that is the x value. All right, so here are your homework problems. Number 42 is the only one that I'm asking you to solve using Desmos. Okay, but again, I'm asking you to solve using Desmos.